Yo, Chuck.
Okay, this video is going to be on Leetcode 300, longest increasing subsequence. So the problem wants us to find the longest subsequence from an array we're given that is constantly increasing. So to give you an idea, the first one, the answer would be length 4 because you have 2, 3, 7, and 101. Notice when you're doing this problem, it allows you to skip elements. So I skipped this 5 and I go to the 3, 7, 101 to get the longest length. This is going to make the problem significantly harder because you can't just say, is the last element I compared with less than the current element, yada, 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 and then increment some type of counter. You literally have to find the most optimized length subarray or subsequence. This makes it very challenging, so we're going to use dynamic programming to solve for this. So the next problem, same thing, you have 0, 1, 2, and 3. I also want to point out, notice if I was to say 0, 1, and then 3 right here, this would actually limit highest length of subsequence I could get to 3, but the answer is 4 because there would be no element greater than 3 after I hit 3. So that's what makes this problem so confusing in my opinion. And then finally we have this edge case of if they're all the same, which isn't too hard to figure out. So like I said, we're going to use dynamic programming and let's get started. So here's the array I've chosen. It's the same array from problem set 2. And we're going to use this to explain how to solve for this problem. So again, we're using these elements for a length of 4. That is going to be our answer. So here we have that nums array again, and we're going to use dynamic programming. So we've created an array called DP, which is set to the same length as nums. Instead of using the elements in nums, I'm just using a 1. And what this is going to represent is at index I, I'm going to basically keep track of the longest subsequence I've discovered thus far in this DP array. So initially, we can set every length to 1 because at the minimum, the longest subsequence would be just 1, right? The very minimum. We're going to have a variable I, and that is going to basically iterate through the nums array. We're starting at index 1 right here because we're going to compare it to a variable j. So I is just going to be a for loop, and then nested inside of I is going to be a for loop for j, and j is always going to be less than I. So it's always going to trail behind I. And again, I is going to be used in j to keep track of the current subsequence length, and then we're going to manipulate the DP array and update it accordingly. So you'll see what I mean as we go through the individual steps. But here is the for loop that we're using. Notice how I is going to be set to 1, and it's going to loop over nums.length. So it's going to loop over the entire nums array. And then nested inside of the for loop for I, we have j. J initially starts at 0 and is less than I. So it's never going to be equal or greater than I. So it's always going to trail behind I, okay? And next, I want to draw your attention to this if conditional inside of the for loop for j. Basically, we're going to compare nums at I to nums at j. If nums at I is greater than nums at j, we want to do something. So if this number is greater than this number, we want to do something. And in this case, we would do something, right? So we go into the if conditional. We know that nums at I is greater than nums at j. So here's the crux of the problem. We're going to update our dynamic programming array at index I, and we're going to take the max at dp at I and then compared with dp at j plus 1. Recall that every item is initialized to 1 at the start. So we're going to take the max of that and then compare it to dp at j plus 1. This is basically a way to keep track of the subsequences we have and see if they're larger than the previous subsequence at that specific index I. Okay, so again, a little convoluted, but you'll see as we go through the problem, step by step, how it all makes sense. Okay, so firstly, we start with our nums array and dp set to 1, 1, 1, 1, 1. And now we're going to say, is nums at I greater than nums at j? Is 1 greater than 0? Yes. So we're going to go inside to this logic right here, right? I have it put right here in this gray text. So you can kind of see it. This is true. So we go into this logic. What is the max of dp at I, which is 1, and dp at j plus 1, which is 1 plus 1 is 2. Well, that's 2 is the max of that. So we're going to update this dp at I to 2. Then we increment I. So I gets incremented. Same step. Is nums at I greater than nums at j? Well, 0 is equal to 0, so no. So we can just increment j. Is nums at I greater than nums at j? 0 is less than 1 actually, so no. So we're just going to increment I. Notice j goes back to starting at 0, and we repeat the process. Is nums at j greater than nums at, is nums at I greater than nums at j? Yes. So we go into the if conditional, and we're right here on our dp array. This is where index I is. So we're going to say, what is the math.max of dp at I, which is 1, and then dp at j, which is dp at j plus 1, sorry. So again, that's 2. So we're going to increment this item, this element in dp to 2, which we do. And now we do the same thing and we increment j. Is nums at I greater than nums at j? Yes, we go into the loop, the if-else conditional, and we say, is dp at I, what is greater, dp at I or dp at j plus 1? Well, dp at j plus 1 would be 3, so that's greater. So we're going to increment this to 3, increment j, same thing. We're gonna say, is nums at I greater than nums at j? It is. We go into this logic. What is the math.max at dp at I, which is 3, and dp at j plus 1, which would be 2. So 3 is still greater, so we don't have to do any changes here. And now we can increment I, j starts at 0 again, and we repeat the process. Is 2 greater than 0? Yes. So what is greater, dp at I or dp at j plus 1? Well, dp at j plus 1 is 2, right? Because 1 plus 1 is 2, and dp at I is only 1. So we're going to update this to 2. And now we can increment j again. Same process. Is nums at I greater than nums at j? It is. We go inside to this if-else conditional, and we say, what is the max of dp at I and dp at j plus 1? Well, they both equal 2. No, this actually equals 3, right? Because dp at j plus 1 would be 2 plus 1 equals 3. So we're going to update this value now at dp at I to 3. Increment j again. Okay, same process. Is 2 greater than 0? Yes. We go inside this loop. We're now here, and then we say, what is greater, dp at I, which is 3, or dp at j plus 1, which would be 2? Well, 3 is still greater than 2, so we can just skip this one. Next step, is nums at I greater than nums at j? No. So we're gonna increment I. Same process again. So little repetitive, but you can kind of see the pattern forming as we are just updating our dynamic programming array here to give us the longest subsequence we found at that index I thus far. So right now it looks like the max we found is 3, but we know the answer is supposed to be 4. So let's just see how this last loop plays out. Okay, so is nums at I greater than nums at j? Yes. What is greatest here? Nums at dp at I or dp at j plus 1? Well, dp at j plus 1 is 2, and dp at I is just 1, so we're going to update this to 2. Same thing, is 3 greater than 1? Yes. What is greater, dp at I, which is 2, or dp at j plus 1, which is 3? Well, 3 is, so we're going to update this value to 3. We continue. Is 3 greater than 0? Yes. And let's make sure I'm looking at the proper indexes here. Is dp at I, which is 3, greater than dp at j, which is 1 plus 1 equals 2? It is, so we don't actually update this. We're just going to increment j. Is 3 greater than 3? No, so we can just increment j, and then this is a final iteration which will give us our answer. Is 3 greater than 2? Is nums at I greater than nums at j? Yes. So we're right here. J is right here and I is right here. And we say, what is greater? dp at I, which is 3, or dp at j plus 1, which is 3 plus 1 or 4, and that is 4. So we're going to update this final value to 4. So you can see as we've walked through these steps how we keep track of the maximum subsequence length we found thus far. In this dynamic programming array, the greatest length we found thus far actually happens to be the very last element in our dynamic programming array, but that's not always the case. Sometimes this largest subsequence might appear somewhere earlier. Like notice how we go 1, 2, and then back to 1. Like this could have been the greatest subsequence in the array. So that's worth mentioning, just not to be confused, okay? So that's kind of a convoluted problem and not easy to wrap your head around, but just know that we're keeping track of the subsequences with that index I and then updating accordingly. So now that we've conceptually explained the problem and how it works, let's hop over to the code. All right, so we're in the code editor now, and we've got a function called Leetcode 300, and notice I'm passing in that array of nums we're working with. So let's just return that nums to see and make sure this all works. or on the code, it returns it. Cool. Okay, so like we explained, we're going to make a variable called dp, which is going to be that array of the same length as nums, but filled with all ones to start, right? So I'm going to say new array, and then I'll pass in the length I want, which is nums.length, and then we can use the fill method and fill it full of ones, because at the very least, you're going to have a subsequence of at least a one, right? So let's return dp now. And you can see it's the same length as nums, and it's full of ones. All right, so just like the loop we explained in the video, or the earlier part of the video, we're just going to make a variable I, and it's going to be set to 1. And I is going to run over until nums.length, right? And we're an increment I. And then inside of I, we're going to have that j variable. And j is going to be equal to 0, but j is going to be less than I. So it's always going to be trailing behind I, never going to quite hit I, right? And then j++. Okay, so from here, we're going to do our if statement. I'll say if nums at I is greater than nums at j. If that's true, we want to do something. And that something we want to do is update the dynamic programming array at index I. So I'm going to say dp at I is going to equal math.max dp at I compared with dp at j plus 1, right? Okay, and if I do that, it's going to update our dp array. So let's actually return the dp array to see what we have so far. We'll clear this and then run that. And that looks good. That looks like in the slideshow what we came up with. Okay, so very simple. We just need to grab that 4. Recall that sometimes the largest subsequence will appear at different indexes. So we couldn't just do something like that, right? Because that would just give us the wrong answer and other problems. So what we actually want to do is we can use math.max again, and then use the spread operator in JavaScript and put dp, and that's going to basically take out the components of all these elements and then find the largest. So let's return that, and it's 4. If you're using a language that doesn't have something like this handy, you could also do something like let max equal 0 or negative infinity, and then you could just loop through the dynamic programming variable. So dp.length, and you would do, max equals math.max, and then you pass in max, and then you pass in dp at I. So basically, this is doing the same thing, but it's a little more clunky. Now I can just return max, and that will give me the same answer as well. So there you have it. That's Leetcode 300. I think it helps to walk through those steps. If you're still not getting it, just go step by step on maybe even a different array than this one, and it'll kind of click, but it's definitely not an easy problem. So I hope you guys enjoyed this video. I will see you in the next one.